Hello, everybody. Moses Frost here, and I'm coming to you live from sunny South Florida. As you can see, it is a sunny day today. I'm on my way to the Agile International Conference over at the FIU campus in Aventura. And today's topic is actually going to be about quantum computing. So, yesterday I recorded a podcast episode with the CKRTL or Control Panel podcast, which will be coming out, I guess, in a bit. And one of the topics, or one of the final topics that we discussed, was quantum machines, quantum computing, and Well Shore's algorithm. Now, I butchered that. I know I butchered that because quantum mechanics is not my field of expertise. And to be quite honest, I'm not sure who that I know that would understand quantum machines at a deep quantized level. However, Shor's algorithm, the idea is that it can do one thing very well, and that is find prime numbers, not only by instantaneously, but pretty damn fast. And so the idea behind Shor's algorithm is you have a large number like RSA 768 or 786. And in order to find it on a standard classical computer, it would take you a very long time, maybe 1,000 years or 20 years or whatever that number is, depending on your computer, of course. However, with Shor's algorithm and a properly designed quantum machine, you could find you could find these numbers fairly quickly, and that is the concern that everybody has: is that most of our encryption technology today, TLS 1.0, TLS 1.1, etc., is based upon or predicated upon RSA or some derivative of RSA, such as DSA. Now, with that said, the idea is that these quantum machines could break at least asymmetric cryptography, right? Symmetric cryptography seems to be okay. Hashing algorithms are fine, are somewhat okay, but there is something known as post-quantum cryptography that everyone is starting to move towards, and so that was part of the idea behind my conversation tomorrow, or yesterday, I mean, is to get people to discuss quantum computing and post quantum cryptographic algorithms that would allow you to basically avoid these type of decrypt problems. Now, for those that have not been in the field all that long, it turns out that we still have issues rolling out crypto in any meaningful way. Just the other day, I found out that Let's Encrypt is going to start to allow you to do 6-day rotating certificates with 6-day expirations, and that's perfectly fine with me. That doesn't necessarily solve the problem, because if somebody were to have a quantum machine, key recovery is not an issue. So what they're doing now, what the standards bodies are doing now, is they're proposing a few things. One of the things they're proposing is the idea of post-quantum cryptographic chips, or sorry, algorithms. The other is hybrid algorithms. Now, the hacker in me is going to start thinking about this and saying, you know what? If you are designing a system that is a hybrid system that's very hard or complex to break, there might be bugs in that software stack that I'm going to want to look at. So I would avoid the hybrid implementations if at all possible. I think there's some strongly worded suggestions around that. I would definitely look at the post quantum cryptography algorithms. There are different ones for different use cases. And well, to be honest, it's going to be a while before we figure out which ones are perfectly okay. So just get used to a world of post quantum crypto in the future.